Everyone, welcome to STEMAC. Today we're gonna learn about a new topic which is known as oxidation state of a electron or atom, of an atom. So what is the oxidation states? That oxidation state indicates that the number of a electron lost or gained by an atom. It actually means that if you gain an electron, it gonna be like this. If you gain an electron, it gonna be negative oxidation, and in case of positive oxidation, it gonna lose an electron and it give it to other atoms. So in case of positive oxidation, we're gonna know that loss of electrons in a short term to remember it perfectly. Example here, iron 2 plus has an oxidation number of +2. That means irons can lose 2 electron and give it to the other atoms. And in case of negative oxidation, it is the gain of electron. That does mean look at those iron 2 plus, it gonna give it to another electron that we learn here. So that other 2 electron gonna get here and give it to a new molecule where its oxidation number gonna be negative. And in case of the example states, chlorine has an oxidation number of -1. That means chlorine can gain 1 electron. And why it happens? Like chlorine need in the last states, we know that in the last orbital we gonna have 8 electron in total. So in that case of chlorine, here 1 electron is missing, so it gonna have that 1 electron here and gonna have a overall situation. That's because it gonna have a negative oxidation state. Here for a few moments here, elements in their elemental form, uncombined form, we need to know that in uncombined form have an oxidation number for 0. In here in oxygen O2, it gonna have 0, H2 and 2 chlorine in those elements gonna have 0 oxidation number in there. Always it can happen with those two, and 2 H2 oxygen, 2 oxygen here. And in case of monoatomic ions have an oxidation number equal to their charges. Like here chlorine, we know that -1, here a minus happened here, so here it has a oxidation number -1. So here the monoatomic states, because of that the charge here gonna have the actual oxidation number. Sodium +1 have +1 oxidation number, and iron 3 plus have +3 oxidation number. Later we're gonna know about the part of iron 2 plus and iron 3 plus, the difference here. So next, hydrogen oxidation number have normally +1, but in case of when it is in a metallic hydride situation, it gonna have -1. Look at here. H2O. Just we got to know about the H. What is the number of case of H? So here H, we're gonna have X here. We just need to know that the H part is X. So 2 atoms here, so we're gonna have cross 2 and plus oxygen H2O. So in case of oxygen, it gonna have -2. Sorry. In case of oxygen, it here is 1. So 2x equal here -2. So what happened? X equal -2 minus a here. In case of that side, it gonna be +1. That in case of H2O, it gonna have +1. In case of sodium hydride, it gonna, in here sodium has +1, or so here it gonna have -1. And next we're gonna learn about a new topic. We're gonna learn about some different thing. Some electron can show multiple oxidation, and which are the electron? We learned that Fe2 plus and Fe3 plus can show multiple oxidation state. So here for the in case of FeCl2, it gonna show oxidation number +2 in case of iron and +3 in case of FeCl3. And here is the another example, copper. Copper gonna have copper 2O. In that case of it gonna have +1, because why it has +1? We know as before we learned in H2O, copper 2O, we gonna have X here and 2, then oxygen have -2. So here 2x minus 2, 2x 2, x equal have 1. So here gonna have +1 and +2O +2. What is the case for here? Copper, oxygen. So here X for copper and oxygen -2. So here 0. X gonna have plus minus, that gonna have minus, and in that case of +2. So here the +2. Y in case of copper oxide it gonna have. So in case of nitrogen it has -3 in case of NH3, and NO3 it gonna have +5. That's all for in case of different same molecule have different states of oxidation. So now we gonna have learn new thing. In case of alkaline metals, group 1 always have an oxidation number of +1. Here sodium chloride, sodium gonna have +1 because chlorine have -1, sodium have +1. +1 -1 gonna have 0. So here sodium gonna have +1 in case of alkaline metals. Alkali metals. So in case of alkaline earth metal group 2, it always have an oxidation number of +2. Here calcium chloride, we're gonna see the equation here. Calcium we're gonna have here calcium chloride X plus here -1 for chlorine into 2. So here X -2, 0, X gonna have +2. In case of here we see calcium chloride, how can it the calcium has +2 in case of alkaline earth metals. In case of halogen, the oxidation number always gonna have -1. Here sodium chloride with here, so that +1 -1. Chlorine oxide, chlorine gonna have +1 here, oxygen gonna have -1. So that's it for here. And the sum of an oxidation number in case of polyatomic ion is equal to the charge of the ion. Here SO4 to -2, it gonna have the oxidation number of SO4 to minus. And why the oxidation number? Oxidation number is important. It helps us to identify a redox reaction, which is electron gain and loss things. We're gonna learn about the redox reaction in next class. So use it. Why it is important again? Used in balance a complex chemical equation. Why the equation is looks like the calcium chloride, like just imagine that case -1. It doesn't properly cause chemical reaction with others. So balance the equation in case of chemical reaction. It is important to have a proper oxidation number, and it determine electron transfer in an ionic compound. When electron gonna lose some electron, when it gonna gain some electron, those oxidation number gonna show that things. And that's all for oxidation number, and next class we're gonna learn about new thing. That's all. Thank you everyone.